me, and you want to phase through this wall. You might say, Annika, what are you talking about? You can't phase through a wall. And you'd be right. Usually. I want to talk to you, or teach you, about a little thing known as quantum tunneling. Now, let's talk about normal physics for a second. In normal physics, this ball here, if you shove it against a tissue box, it's not going to suddenly appear over here. You can shove it really hard, and it could break the tissue box and appear over here. You could go around, but either way, it would still damage or change its trajectory to get here. But let's shrink this down to the atomic scale, where things get a lot more strange. Let's pretend this ball is an atom, and this is a barrier. Now, if we were to take this atom and shove it into the barrier, or in the direction of, it could appear over here. This is just a possible place it can be. But I want to tell you why this little indiscrepancy, when you apply it to that, does not help you. It doesn't. Let's look at this notebook. This notebook is an even thinner barrier. The chances of this ball quantum tunneling through this barrier are a lot higher than the tissue box, because this is a thinner barrier than this one is. Now, this is on the atomic scale. How big do you think this is? This thick actual wall has so many atoms, and my hand has so many atoms, and is so thick, quantum tunneling, basically impossible, because not only would the atoms have to align correctly, they would also want to go through the wall, in the sense of like wanting to be on the other side of that barrier. You know, align in the sense where their electromagnetic forces will allow them to go through, that this number is so small, it might as well be 0. If I were to hit my hand against this wall from the beginning of the universe to the end of the universe, I still wouldn't phase through. There is a chance, and of course it does increase every time you hit your wall, that doesn't exactly guarantee you. But because it technically is non-zero, there is still a chance. But it is so small, it's basically 0.